So yes, I'm the president of our engineering firm, Chang Industrial. Matt Chang is the founder of the group. We were founded in 2017, and we do basically engineering and technology solutions. So before we get into it, I have a quick quiz for the room. Just shout it out if you know any of the images as they come on screen. Spot. There we go. Spot, the robot dog, Boston Dynamic.
Boston, nice.
How about that one?
It's one of those hospital robots, right?
Yeah, so there was recently a couple news articles from Baptist Health about the Moxie robot. So this is an image of that. It's a test case they're trying out over at Wolfson's in the hospital downtown. How about that guy?
Amazon.
Yeah, that's a Kiva robot. Yep. Everybody should know that one. Roomba? Yep.
And
Okay. We're going to talk about most of them. We're probably not going to talk about Arnold Schwarzenegger, but it was a good test to see where... Yeah, we did. So yeah, about us, important concepts. So we're talking about autonomous systems. That's our niche in engineering. And then kind of the outlook. So the title was Transforming the Paradigm of Industries with Technology. Basically, how are we helping any industry, specifically within the supply chain network, develop to be more efficient, safer, and provide higher quality to everybody in this room, all consumers. Even if you work at one of those industries, you're consuming something from another one. So what's the outlook for the next 10, 20, 30 years? So like I said, we're an engineering firm. We focus on technology and innovative solutions and how to bring the best bang for your buck to, we'd say, an end user or client. And that usually comes in different forms of robotics. We do the engineering. We have a number of partners within different industries that have different robotic solutions. So we don't manufacture anything. But if you're looking for some kind of a solution, usually we're the ones that can help develop the turnkey solution that integrates with your facility, whether it's fire doors, alarm systems, identifying safe access points, and how you do people safety and robotics at the same time. So that's kind of where we come into play versus just a client and a robotics manufacturer. This is just a brief overview of some of the different industries we are pretty grounded in. Manufacturing for food and beverage companies. We work with a number of different local government entities on innovation projects. And then you can see on the bottom, Coca-Cola Taiwan is a factory of the future design. So we do international design as well. We have a number of different architects and engineers that have different licenses across the world and can provide solutions no matter where it is. It just means a lot of nighttime and evening calls for me. So just real quick, I was actually talking about this just before we started. Difference between autonomy and automation. Most people probably know it already. Automation is very pertinent in any conversation you have these days. And I think the important thing is it's been around for a really long time. Anything from an MDR, like roller conveyor, right? That's automation. Everybody has roller conveyor, right? So and it's not to say that it's not important. Every facility uses it. The difference is autonomy is the next level of automation in that it's becoming self-sufficient and it's taking advantage of AI, machine learning, vision systems, sensors to become a self-educated and learned system that can eventually operate without human interaction. We're not there yet. As you'll see in some of the use cases I present, we've developed a number of autonomous systems that we've implemented in different areas. All of them still require human interaction. Either someone's monitoring it, they're troubleshooting it, what have you. A robot gets stuck in a corner and can't figure its way out. Something happens and there's a human that has to come in, and whether it's, remotely accessing it and just typing something in, or somebody that literally walks over with what we would call a leash, which is just kind of a plug with a button, and manually walk it back and be like, okay, go on your way now. If anybody has a Roomba, I frequently get messages on my phone while I'm at church that your Roomba's stuck on a cliff. I never installed cliffs in my home, so I don't even know where it is, but it happens a lot. So the technology is progressing, but it's not 100% there yet. But we do believe at Chang Industrial that autonomy and autonomous systems is the future for industries, transportation, you name it. So before, a lot of people like to save videos and like the exciting part to the end. I like to get everyone engaged now. So this is a short, about 3-minute video, and I'll try and talk as we go through on just what our autonomous systems and our approach looks like. I can start. There we go. So this is what you see on the bottom is one of the form factors of an autonomous robot that we've implemented. On top of it is a customized tooling. It's a roller top. And you can see that it's interacting with we've simulated a existing legacy piece of equipment, and it's coming and picking up a load, and it's going to go drive that somewhere else. This is a lights out test of these, and what you see is the scan. This is the LiDAR scan. We're simulating a pickup and drop off of the larger payload of like a pallet, and you can see in the back corner it's engaging with a stand that we designed, and then there's a guy over there. This is a screenshot of the fleet manager. This is what tracks AMRs and how they're moving. Everybody probably knows what an AGV is, an automated guided vehicle. These are a fork truck without a driver. We've implemented a couple of mixed fleet systems where you've got both AGVs and AMRs running, so this is a test of a pickup.
The previous robot, how much weight can it hold?
Uh-oh.
Uh-oh. I didn't do it.
Well, you fix this. I will answer your question. The smaller one?
The first one, yeah.
That was we call that an Auto is the company that manufactured that one. That was an Auto 100. The number stands for the kilograms of payload so basically 220 pounds. And then the larger form factor that you saw, and you will see again, that's a 1,500 kilogram, so that's about 3,300 pounds.
Wow, it's over a ton.
Yeah. This is a performance test we were running for the Auto 100s. And the point was, you see these boxes in different areas. We dropped different obstacles around to see how well they navigated when an obstacle. And this is what we love about autonomous systems, is they will find their way. They don't stop. They just find their way. This is an example of a lights out test. So let's say the facility loses lighting. If you lose power altogether, you're in a different situation. But if you want to operate at night, save some electricity bills, these machines can run totally in a lights out or a dark facility.
Lithium batteries, right?
Yes.
So do they automatically go back to our charging station?
Yep. Yeah.
On their own, or do you have to manually?
No, so there's this is all part of the system setup. Is you set critical battery levels for the system, and so what'll happen is if it's at 21% battery life, it's going to take the next mission, which a fleet manager will assign whatever the next mission is. It gets assigned to whatever the next available robot is. If it's at a 20%, it's probably not going to take it because it knows if we set the limit at 20%, say, if the battery is at 20%, it's going to say, I'm not available. I can't take that mission. The next thing I'm doing after I drop off the payload on my back is I'm going to charge. So that's how you can play with that, right? If you wanted it, you could set it at 30%, you could set it at 5%. That's not recommended because they could be, if they're at 6% and they go to do a mission, they might run out of juice on the way to charging. But yes, you can set the critical level at whatever you want it to be within the system. We generally do about 20%. Go ahead. So this is a smart lifter and assist that we are using to test one of the customized tooling that we built. This red thing is a cart. Sorry, can you pause for 1 second? The red thing is a cart that we custom built for the smaller AMR to drive under and basically lock, and then it drives the cart around. And so what you're seeing here is this is simulating a roll of filter paper, which is roughly 60 pounds. So an employee is not supposed to, by OSHA and NIOSH standards, is not supposed to lift that by themselves. So use a smart lifter to attach it onto this custom tooling, And then on the end, when it gets to the product line or the packaging line, the robot has a docking station where it drives up and there's a little pusher thing at the end of this tube, and it will actually engage the filter paper into the machine by itself, so a human doesn't need to lift it or move it. And then this is a screenshot of our simulation. Basically, in any of these implementations, we'll take 12 months worth of data, inventory, orders, everything, and we'll then simulate a traffic pattern of the facility. We can do that both pre with fork trucks and then post with an AMR solution. And then this is, again, the screenshot of the fleet manager. So what you have are two different AMRs. One's leaving the screen, one's heading to dock with a stand. These are the stands here. I think in a second what you're going to see is what it looks like in real time as the AMR is getting ready to drive in. Yeah. So this is the horseshoe stand. The lift is going up, so to pick up a pallet, they don't have forks. That's the downside to AMRs. They don't have forks. So we have a lift attachment, drives into the stand. And while that's happening, this is what anybody monitoring the fleet manager sees on screen. It'll stop, disengage the lift. And then the pallet will stay and the AMR will back out. And that's as soon as it backs out, that's when it becomes available for a new mission. And fleet manager will take whatever the next one on the list is, assign it, and it will go off and do its next thing. All right, so that was the fun part. This is our design guide. This is what basically the different tools that we assess when we're doing a design. So up on the top, you have drone head, which is basically the industry standard buzzword for an AI package, right? All of the different elements that what's making the system smart and what's the robot thinking about. Fleet manager on the bottom is, where does all of this information go? How does each of the robots know where things are going, where they're coming from? If you have a mixed fleet, I referenced, you have AMRs and AGVs running together. And most importantly, what is the traceability within your facility? How are you keeping track of where all these things are moving? Which is the enterprise level, right? We'd like to think that with each of these systems, we're developing a next generation of data, because you now are basically recording movements that were generally not recorded or accounted for because it was all manual. And so now you have this enterprise, data analytics that can be done because you have a new set of tools to keep informing yourselves in your enterprise on what's happening and where things are moving, where there are hang-ups, where there are bottlenecks, all those kinds of things. Communications, this is, for the IT folks in the room, this is hugely important to any project. We usually will let a client know at the beginning of a project that, as we all know, supply chain is, pushing out, lead times are long. But what we're experiencing is any project that we do, the lead time for the IT side, for the integration and the communications that need to be set up for these robots to be functional, how do we integrate with your order system? How do we know how to generate those orders to fleet manager? That lead time for a project is generally just as long as the lead time for the, manufacturing and production of the vehicles. So it is critical to have the right stakeholders at the beginning of the project to make sure you're getting all those integration steps taken care of. Because the nice thing about these systems is you could start with 2, right? You could integrate 2 robots into your facility, see how it works. And once you've done that from the IT side, you can add 20 more almost seamlessly. I'm not going to say it's totally seamless, but you have to, you ship them to site, you get them plugged in, you basically map them into the navigation system that's already generated, and they just start taking missions. So that's the great thing about these systems is you can grow it, as your inventory or your volume grows, you could add 1 or 2 more systems. When I was talking about automation versus autonomy, that's, again, I love conveyor. It's really good for what it's for. But the downside is you have conveyor legs and, structure everywhere on your facility that cannot move and cannot adapt. And these systems can. The form factor and the powertrain, that's basically just kind of what you see of the robot, right? That's the structure, that's the vision system built into it, the sensors, the charging that needs to be done. And the most important part about that is, as we're informing anybody, is that's roughly 50% of a project cost up front, is just getting the robot and the stands that were manufactured. Yes.
So out of curiosity, I mean, you're implementing robots. You're ultimately taking a person that maybe driving a forklift. What kind of ROI is there? I mean, obviously these robots aren't cheap. I mean, do you approach the customer and say, if we did 3 robots, it's going to, based on what you pay salaries, is that part of the business conversation? And
Sure.
Where does that stand? I mean,
Yeah, 1,000%. So we approach every project on a CapEx equivalency at the beginning. So here's your cap. This is your budget, right? This is what it costs upfront to implement the system. This is going to include the design, the purchasing of the robots, and whatever custom stands or tooling or whatever. Your IT package will work with the client to figure out how much engagement they need and price in their project manager for IT. And here's your whole cost from our team, from the robot, and consider what you need to spend internally. This is your CapEx. And then what we'll do is we'll say, but let's take what are wages today, what are wages in 5 years, how many roles are you, tasks are you removing, and we'll do a business case and a return on investment. Generally, these systems pay back in about 3 to 4 years. And then what we found is on an OPEX, on an annual basis, you're spending somewhere between a third to a fifth of what you would spend for that same labor. Now, that for a fork truck, that includes the drivers renting or buying the fork trucks themselves. Usually they run on propane, whatever all the elements that feed into that. But there are other things to consider, such as, attrition rates. We did a design for a large retail company in which their injury rates were so high because of the amount of people that had to get on a lift, go up 5 stories, and pull a 60-pound mirror out of a rack, right, by themselves. Whereas when you receive it at your house, it says on the box, team lift, right? And it shows the 2 people lifting on either side. But you've got individuals on a lift going and pulling these things out of rack by themselves. And 1, trying not to fall off the lift. 2, trying not to break the piece of whatever they're pulling. And then getting it safely to the end shipping point to send to you. And make sure they don't, if they break it, then there's an issue with quality. And then they end up with shoulder and back and all sorts of injuries that either set them out of work or cost the company money for, continual occupational therapy. So those kind of things need to factor into the business case too.
So do you see with the labor shortage nowadays, a lot more companies starting to implement these because of the shortage of labor?
Yeah, we've become somewhat flooded with requests to start doing. We'll do anything from a feasibility all the way through a full detailed design, but we'll start with feasibility, just to come in and look at, can you even operate robots in this environment? And then if you can, then we can go on to the broader question of what does the design look like, and then what's the cost and the payback. But one of the things, somebody asked me, how do you feel about taking jobs away from people for robots? And my response was, 1, there's a labor shortage, or, I forget how it was phrased to me. Just, what did you say this morning? Not a labor shortage, but a labor misalignment. Thank you. Going on. And so there's so many jobs that can't be filled right now. The Keurig Dr. Pepper work we did, we were about a month or 2 away from finishing the testing and doing our final performance test. And the client was like, we need to go live now. We need to expedite this. Let's go, we'll pay you to go 24/7 on testing to expedite the schedule because we cannot staff all of the roles that we have in the facility now. We need the AMRs up so we don't need to bring in as many people.
There's like 700,000 unfilled manufacturing jobs right now.
Yeah.
So it's one of the things that the institute is focusing on too, is how to get people into manufacturing.
Yeah, manufacturing is just one, right? We're working with a local healthcare facility here in town, and it's because there's like 1,500 vacancies in the nursing industry. And then the nurses that are working are burnt out and working double shifts and are tired of having to fetch linens or take dirty trays away or simple tasks that really are not their job and is not what their focus should be as a healthcare provider.
So they look a little slower than what a human would do with a electric pallet jack? But,
Yeah.
But they don't take breaks and they don't take lunch breaks. So,
That's, this is what I like about, and I'm sorry, I saw other hands, I'll come back in a second, but this is a great snapshot of what an autonomous system looks like, right? So you see the red lines are the path that was mapped into the system. I like this one better just because it's more like spaghetti. But the red lines are what was mapped into the system. All of these other lines, you see the colors are each of the, there's actually a list of AMRs, it's kind of hard to see, but each AMR is a different color. All of these lines are the paths that the AMR chose to take to actually get from point A to point B because of whatever. It could be, there was an operator standing right where they needed to drop off, so they went around them. Or it could be that there was a fork truck. During testing, we aren't at 100%. You don't go from 0 to 100% on these AMR tests right away, right? You have to ramp the system up. So there are certain materials that need to be moved while we're testing AMRs. So we were doing fork trucks and AMRs in the same pathways. And so if a fork truck's parked where it shouldn't be, an AMR is going to stop, scan, and then figure out how to go around it. And that's what all these lines show.
So I was leading to my question. Are they working around the clock, or do you find that your customers kind of just shut down, everybody goes home, or when people go home, these things are just still busy bees?
They can run 24/7 for sure. Usually they need, if you ran it at full capacity for 8 hours, it's going to need to go charge for about 1.5. So we like to install.
So it does take a lunch break.
Yeah, or an app or whatever you want to call it. So what we do is we implement opportunity charging, whereas if it finishes a mission and there's not another one slated for it just yet, it goes and grabs a charge for 5 minutes. And then as soon as another mission hits it, it'll disengage, pop out, and go do whatever it needs to.
Cigarette break.
Yeah, smoking break. And yeah, usually what we do is we design the system to, if you need to run 14 AMRs all the time, we'll probably implement 16 or 17. Sometimes it depends on the appetite of the client on how many extra they want to invest. But that allows for if one goes down for maintenance, or if one is out grabbing a charge or a smoke break, you're never running low on capacity. And what we usually also do is we design the client's system to manage 60% of what they think they need. And what we'll do is we'll implement it at a 60% rate. So here's your 14 AMRs. You think you need 20. We're going to put in 14. Prove to us that you actually need all 20. So run the system. And like I said, the minute that you start hitting capacity, we'll get a couple more, we'll plug them in, and you'll be good to go. But let's not stretch your budget so far before you know that you need to. So that's what we love about these, is that the system is scalable, and basically you're at the mercy of whatever the lead time is on producing the robots to add a couple more. Yes.
What's the lifespan of these things? Is it hours ran? How do you handle maintenance? Is that part of your contract with these companies?
Yeah, great question. The lifespan is about 10 to 12 years for the AMRs. The AGVs are at about 15 years now. That technology is a little more matured. And it's all based on, obviously, just like you get your Roomba, there's recommendations on how to run it, how to maintain it, how to keep it well functioning. There's preventative maintenance that goes on basically, there's things that are recommended on a daily basis. And those can either be procured directly with the OEM, or we can provide some kind of what we would call like a continuing services agreement. And we do provide that also. We have not just engineers, but we also have robotic technicians, and we have site managers. We have everything you would need to stand up a system, quality and testing, and then also do service and maintenance on it. And what we like to do is implement basically a 1-year service agreement, in which we're also, the great thing about this is we like to focus on workforce improvement when we're implementing these. So while people think, oh, you're taking jobs, I would say no, we're providing more technically advanced job opportunities for those people, because now instead of being the person that's driving something just back and forth all day, you now get to be the one that's maintaining or managing the robot, right? Now you get to be the overseer, you get to log into Fleet Manager and see what's going on. So we like to think of this as an upskilling opportunity for people at the plant. where they get more of a technically advanced training. And that's why we do it for about a year, is ideally we provide that service for a year while your team learns from us. And then after that, we encourage you to then, go on. And you're not going to be left high and dry. It's not like on day 366, it's like, okay, bye, There are 24/7 call lines and everything else. But the idea would be to train your workforce to be able to do this as well. Did that answer your question?
Yeah, no, that's
Okay.
good.
Back in the dark ages, you had your principal engineers designing your plant, your workflow and all machinery you had around it. Is there some methodology you're using now to do that, since now you're trying to automate those processes as opposed to having people run through aisles and stuff?
Automate all of the different.
By the design of the environment, because
Yeah.
you still have to have the production machinery, or whatever types it is, the
Yes.
to the.
Yeah, so what we'll do is I talked about feasibility. We'll come in and we'll look at everything from your aisle widths, what materials are moving, how often they move, the size. One of the raw materials we moved at Keurig was super sacks, which are not a form that is consistent, right? It's just a big 2,000-pound sack of coffee, and it can have an overhang one way or another. So we did have to develop certain requirements around, how much of an overhang can we allow before an AMR can't take it anymore, right? So then there is certain, the human has to check and be like, all right, we set it on and it's more or less straight. So we designed a certain stand that basically had like guide rails that if the super sack wouldn't fit there, then it can't go on the AMR. It has to be driven. So we would do that kind of thing. But aisle widths are a big one. Navigation specs are a huge part of the beginning of the design. Each type of robot has a different nav spec, whether it's, I showed you autos, there's Mir and there's Fetch and there's all types of manufacturers out there. And all of them have different specs on, which means how wide do they scan. Basically they can run in like an 8-foot aisle, but they're going to run at a reduced speed. The fastest, like these autos run, is 2 meters per second, which somebody smarter than me probably can do that conversion on what that is in miles or feet. But 2 meters per second, or their slow mode is 0.2 meters per second. And kind of depending on the environment around them is how quick or slowly they'll move. If they've got a clear way, they'll zip off. 2 meters per second looks pretty fast to me when I watch them go. So yeah, we do anything for feasibility, and then we'll move things. We'll move pieces of like packaging lines. We'll say, you need to turn that to a 90-degree angle to make these aisleways wider because there's a pedestrian path that needs to move in 2 feet. And so your legacy equipment has to just be slightly moderated so you can move the pedestrian path in so that the AMRs can run. So that's the kind of life safety and like facility design and feasibility study we'll do, along with just, can you plug a robot in and make it run? You've had your hand up a couple times.
That was a different question now. Are you developing anything that can unload containers or semi-trucks autonomously yet?
We are not developing that. I've seen a couple solutions for it. The hard part in that is that
Everything's kind of different.
you never get a semi-truck that's full of consistently shaped boxes.
Yeah.
Or usually it's just that whoever loaded it on that end, and that makes it really hard for a vision system to find an edge or a corner and be able to pick something.
I mean, even new product coming from China or something, you never know how it's going to be. So it kind of takes a human element.
Yeah. There's some things in development. I think that's one thing that's probably needs a little more development within the industry. I've seen certain things. Honeywell has one that's like a really big. You've probably seen it. And it'll go in and it just it's almost like a vacuum. It like sucks them in, and then it puts them out on a conveyor.
Yeah, I've seen that one.
But the caution there is, what is the quality of the box on the flip side?
Mm-hmm.
So there's still development going on. I know it's not something we're looking at, but I know it's something that's working in the industry. Yes.
So, if I'm a potential client for your services, how do you and I ever link up with each other in the first place?
Well, I'm on LinkedIn. I'm here today. We have a website where you can contact us, but I'm happy, we're not a big company, so we're really accessible. You've got myself, you've got Matthew, the founder. And we've got a couple of marketing gals that are always present, but honestly, if everything we've done so far has been word of mouth, and we take pride in that. So, my short answer is if you're out in California, you just have to get lucky enough to come in contact with us. But yeah, I mean, if it's something you're interested in, then I'm here to connect with you after the meeting. Anybody else? Okay. So we've kind of covered this at length already, but the world is shrinking, everything's connected, and so we just like to focus on the fact that as everything's getting smaller and you can access anything at the basically flip of your thumb, analytics and data are huge in tracking quality, customer appreciation, what have you. So like I said, not just the robots, but everything that goes into it from the supporting features. Internet of Things. So there are a number of sensors that go into these systems, from simple things such as on those stands, when a fleet manager sends an order to the AMR and says, you need to go drop a pallet off at stand 52, we need to make sure stand 52 is empty. And so it's simple sensors that even just like, whether it's just a photo eye or a sensor that you can change from, I need a raw material on the stand to I need a finished good pickup, and we have different buttons that can change that. So as we develop these things, software, and like I said, yes, Johnny? I have 5 minutes left? Oh, gosh. Okay. Well, you guys aren't going to see everything, but so robots in all industries. These are some of the industries we're focusing on right now. You've heard about manufacturing, e-commerce. One of the things we like with e-commerce is there's a system. Pallet shuttles are becoming huge, and they're great because instead of 4 or 5 levels of racking that a person is, by OSHA standards can access, you can now literally cube your building out from floor to ceiling with, and then sprinklers up top, but basically floor to ceiling. With different pallet shuttles that can move in different form factors. I've seen pallet sizes, and I've seen, unit loads or kits, similar to the AMRs. Healthcare, this one down here is a pharmaceutical distribution robot. So, it can drive around and distribute the right type of medication to the right room. Usually they always have some type of security or badge access. In order to access whatever the medication is. You can't just have an AMR driving around a tray of morphine or something like that. So, but that's pharmaceutical.
We're working with a hospital now that has something similar that we're having to redesign the electronic medical record around to work.
Yeah.
That's pretty cool.
And that if you saw the Moxie one, it's the same thing. They have a badge drawer on that one for, with the Wolfsons. Agriculture, driverless tractors are here. They're a thing that is happening now. That one is a John Deere, but there's others out there. Transportation is kind of my favorite right now, specifically long-haul trucking. There's been a number of companies that have successfully done a long-haul autonomously from point A to point B. The most recent one that I know of was at the end of October in Tennessee. We take that with a grain of salt, right? They completed the autonomous trucking, but they coordinated with state and local officials. They worked with Ericsson to make sure that they had a seamless network support and that there were no outages. So obviously it's not something you're just going to run into on the road here, right? I'm sure there were some roads that were shut down and Ericsson was there monitoring it the whole time. But it is proof that the technology is developing and will be ready, and that these things they're not just, the Jetsons anymore. I'm going to probably skip these. These are quick videos. This is a driverless tractor that's spraying and treating grapes and also monitoring them for when they're ready for harvest. This is an all-terrain AGV or UGV. What's that?
It's going fast.
Yeah, these go fast, and they're off-road, so that's fine. When you're doing anything in a facility with walls and people, there's obviously a lot more concerns. And then obviously on public roadways, there's, you have everything from handicapped people, kids with skateboards, you name it. There's so many concerns, but out in the middle of nowhere, have at it. And then we all know Spot the robot dog can climb stairs, can go through doors. So that technology is pretty neat. But I've also seen tests of Spot the robot dog where if there's a Wi-Fi outage, he just falls over, so poor Spot.
Maybe I wanted somebody to give my belly rub.
Yeah, maybe. Instead of a smoke break, he gets a belly rub. Okay, so we're not going to get to go through everything, but are there coffee drinkers in here?
Of course.
Yeah. If you've consumed a K-Cup in the last year and a half, it has probably been handled by one of the autonomous systems that we implemented. The two largest Keurig plants in the country are in South Carolina and Tennessee, and those are the two implementations that we did in the last couple years. The Greenfield site, it's 1,000 square foot brand new facility. Of that, 400,000 of it was dedicated to AMR usage. Those were the little ones you saw, the unit loads. So what they do is they have a kitting area where each individual packaging line might have different needs at any different time. If you think of a K-Cup, there's the cup, there's the coffee, there's a filter, there's a lid. So one packaging line might need cups, another one might need the lids. You saw that filter paper, that's the really heavy thing that gets put in and then it just spins and it has a hole puncher that just punches out these lids or these filters over and over again. So that for this particular one, the Greenfield, we designed it to work with AMRs, so you only needed kits of just kind of real-time what you need now. The Brownfield was an existing facility. This is the one in Tennessee, and this is the one I had the pleasure of being the project director on. Super congested, existing 700,000 square foot facility. It has 30 packaging lines in it, and as you can imagine, it's a building that started here, then they did an addition this way, and then they did an addition this way, and then they came down here with more dock doors, and then they just started sticking packaging lines wherever they could fit them. And what happened is the Greenfield site came online about a year later than it was scheduled to, and so the Tennessee site took all of the product demand for the entire Keurig network that the Greenfield site couldn't fill. So this plant was pushing 120% of what it had ever done. So we're trying to stick some robots in while this plant is trying to do more product than it has ever run in its life. So it was a challenge, but there was a couple times we actually paused because they had so much inventory that they were stacking 4 high pallets just in the aisleways. And as I mentioned, if the AMRs don't have enough aisleway, they can't really navigate, and especially if there's things in the way. So we ended up successfully implementing AGVs and AMRs in this facility. This is a quick view of a real-time. I took this video when I was on site during testing. So it's going through a door, so it's going slow. You see it's got its turn signal on. It's got a payload on its back. So it's going to go ahead, and once it gets through the door, you're going to catch it start to zip off. Yep, there it speeds up a little bit, and it's heading out. And this was during testing, so as I said, that's a driver paying attention to the rules of the road, having to wait for the AMR to clear, and then this is the second one. And what we learned in this, I guess it's going to stop there, but this one also has a turn signal on. It's trying to go through the doorway, but because where we had the doorway, it was so narrow, we learned that the AMRs actually had to kind of do a little jive to reconfigure and get through. So we actually widened this doorway. You can see this little cut here. We made that doorway wider so that the AMRs could pass and actually go 2 ways through the door and be more at speed for more efficiency.
I know we're out of time, but very, very quick question. There's no sound here. Are they making any beeping sounds?
Oh, gosh. It haunts my dreams. This project was implemented finished about a year ago, and I still have nightmares of those sounds. And there actually is sound. Can we get it or no? If we can, it's not a big deal. I can send out a video of it, or I can text you one of the. But yes, it's yes. There's sounds.
Okay, no problem. Just like 2 minutes.
There we go. You hear that?
Yeah, the beeping. I got a truck backing up.
Yeah, that's it. That's its sound that's just emanating that I'm navigating, I'm working.
That's just one.
That's just one, yeah. And then all the background noise you hear is the packaging lines running like over. There's a conveyor overhead of me right there.
Oh, nice.
And then when they get into a troubleshooting mode, all their lights go red, and that's the worst sound ever. It's like, if you've ever seen the movie where it's like, do you ever want to hear the Dumb and Dumber? Do you ever want to hear the most obnoxious sound in the world? That's kind of what it is. So yes, I'm really sorry we're out of time. I actually had a lot more content, but I can PDF this or whatever. You guys can share it, distribute it if you want. So I do appreciate you being here. If anybody has questions, I'm free to stay afterwards. And thank you.
Thank you.